Good morning, ladies and gentlemen. Welcome to Connection Wednesdays. There's another Wednesday, and we would like to welcome you to our new webinar. Today, we will have a look at a project of a balcony console imported from Autodesk Robot Structural Analysis. Let me introduce myself and my colleague. My name is Jana, and my colleague Adam. We are both product engineers at IDEA StatiCa. And let me also mention that you are muted, but you can send us your questions via the questions panel in GoToWebinar. So please feel free to use it, and we will try to answer your questions during the webinar. And also, if we are not able to do it, we will send you an email afterwards. So please send us your questions. So what will we see today? In the main part of the webinar, we will focus on the customer's project. It's a balcony console, as I mentioned before, by the metallerie Antonietti company. Adam will show you how the BIM link with Autodesk Robot works, and he will also show you how to design such a connection and also code check the connection and the anchoring through a wall. In some last minutes, we will have a help desk highlight corner, and we will have a look at the workflow in Excel and in IDEA StatiCa. So if you are used to work with Excel sheets to check your connections, maybe you can have some comparison between the workflow and how you can use also IDEA StatiCa to your simple connections, not only to the really complex ones. So we will have a look at the template library. And now let me pass the word to Adam, and he will show you more. He will tell you more about the customer project.
Okay, greetings from my side as well. I'll just get the screen. I hope you can see that. And I'll just go quickly through a short introduction to the project that we got from one of our customers. As Jana said, it's from the company Antonietti. They're based in eastern France, in the city or town of Aix-en-Port, and they've been on the market for more than 70 years, providing complex services in steel constructions, beginning with design of steel structures and ending up with delivery and building the whole thing on site. They have their own workshop as well, and they've delivered through all these years a couple of very interesting projects, small and large as well. And today, oops, sorry, so it's went wrong with the presentation. That's the right side. Today, I'm gonna take a look at one of their project we got through our HelpDesk channels. It's a, let's say, daily project of a small size. It's a steel balcony construction that's was planned to be attached to an old villa in a village of Selencourt in the region of eastern France. So there was a preliminary draft or a study of the construction. You can see the old concrete wall, and to this attached some kind of a steel structure of the balcony with a concrete slab on top of that, and all of that is anchored through the concrete wall of the current old villa building. So the next step was some kind of drawing. It's also kind of preliminary drawing about the idea. You can see a picture of that villa down below. And here we get to the structural model that was done in robot structure analysis. Very simple steel structure, very simple model. But then there came time to code check the connections and the anchoring of the balcony to the wall. And for that, this company used IDEA StatiCa software connection, modeled the exported joint, and code checked it there. And they liked it, of course. So now let's take a look how they did it and how they modeled the joint. And I'll try to give you a few tips about the modeling of such a model or such a connection. But first, before I start, let me launch a poll. I would like to ask you, I'll turn on my webcam now, and let's get to that. So I'll launch a poll, and now I ask you to answer, to click. How often do you use BIM links to import connections or joints from third-party softwares, from structure analysis softwares? So if you always use them or very often, or only for the very complex joints, or if you use them just sometimes when you feel that would help you to improve the workflow, or whether you have never tried them yet. Okay, 5 more seconds, nearly done. I'm closing the poll and I share the results with you. So yeah, that's interesting. Most of you would say just sometimes or even never. So this could be interesting for all of you to see the workflow or how we do it with IDEA StatiCa. So let's see that. All right. So this is the actual model in robot structure analysis, balcony and a concrete slab. Just to have a better orientation, I will hide the concrete slab components, okay, to have just the steel construction here displayed. And I'll be exporting this joint around here. So how can I do that? I simply select the joint and just drag the mouse from right to left and select the joint and the connected members. But while doing this in robot, unfortunately, I've selected this beam as well, which I don't want to get into my connection because this is connected to this one over here. So this is let's say a feature of robot, an uncomfortable one, but you can simply do it the other way. Just select the joint, hold Control key on my keyboard and select all the connected members to this one. Okay, next I just launched the code check manager, and here I can simply choose the code, which one I would like to code check the joint in. So I'll go for the Eurocode this time. The data is processed. Now a settings window will appear in a second where I can manage the cross sections if I would like to. I can change where the support would be. I can define or treat the load combinations and load effects as I wish, or simply I just leave it all on IDEA StatiCa with the default settings, and I'll get the real geometry, all the load combinations and load effects imported, and everything is on the right place. So here we get the joint. Here we can see all the load combinations that are. I will hide them now because I need some space here to show you the operations I'll be adding in a second. And I've got all the necessary combination or relevant combinations for a project of such joint. So some might have been neglected because they are, let's say, less dangerous for this joint than the others already on the list. So it's, let's say, some kind of automatic filter which helps you improve the computational time and not doing unnecessary calculations. So I'll start with the modeling right away. First, I will use a cut operation, and I will select the column. I will cut it by the main beam, and I will choose the farther cutting plane. So I'm actually not cutting the column, but lengthening it. Then I'll connect the D3 main beam. I will select which bolt I would like to use, as this design was done with M16 grade 8.8. So I'm going for those. And of course, I'm going to modify this operation. I'm connecting the main beam to the column, and I will also define the size of the end plate. Okay, make it some wider to be able to connect these side beams, these U profiles as well. I've defined the type of bolts already, and I will just move them to the right position. All right, and last thing, I will assign the exact size of the welds around the connection. Good. Now I can move on to these side beams. They are going to be bolted to this extended end plate. And first I will cut them and move them a little bit to the right position. So I will use the cut operation. I will cut it by this B3 main beam, and I will use offset here. As I'll zoom in, so you see what it does actually. It cuts this part which is close to the joint or the beam, and provides me with this gap. So I simply copy this for the other beam as well. All right. And what I have to do now, I have to slightly move these members to these beams to align with the end plate here, right? So you can see the gap over here. I would like to have this web and this plate aligned, and I can do this by moving it simply here in the geometry of the beam. As you can see, there is some weld generated, which I obviously don't want to be here. So if I jump back to this cut operation, I simply turn off the weld. Okay, I do this for the other one as well, and I move this one by this 86 millimeters as well. Right, that's in position, and now let's bolt them all together. So a bolt operation, And for this, I'm going to bolt 2 plates, of course. First is the web of the beam. Second one is the end plate that was already selected. I'm using the same bolt size and grade, of course. And I'm going to set those bolts to right position, 40 minus 40 in rows and 40 in the horizontal distance. Cool, that's looking good. Now simply copy this, attach to the other beam as well. That's done. That's pretty simple. And now we move on to another operation, a stiffening plate or general plate that is created with this operation. You can see it here. That's not really what I like to have here, but let's first shape it a bit. 180 by 75. That's the size I would like to have it. That would be like the base plate of the anchoring to the concrete wall, right? I just needed to put it in the right position. How can I do that? I can either use these coordinations and rotate it and so on and put it in place, or I can use the origin type or origin settings, and I would put it or edit the origin of this member, this column, and its top flange, right? So this one is the top flange, not the bottom one. So this is now right like that. And the other setting here is the type. Let's say we've got 3 choices. So if I use the doubler here, that means it rotates automatically the plate and uses it as a doubler to this top flange of the column. It adds the welds as well, automatically generates them. So I only set the size of them to 4 millimeters. But what I lack here, those vertical welds in here, those were not generated, right? Here and on this side as well. So how do I get them in place? Well, pretty simply, I use the weld operation here, the general weld, and this is my first tip for you. Sometimes this is tricky. So now I'm going to connect the column flange, right? So I switch here from plate to member because I'm going to connect a member or weld a member. So I can just simply select it, right? I've selected the flange and I select the plate as well. Right, so now it's right selected. I can input the size of the weld as well, 4 millimeters as is the default size in the design of this one, but I can't see any weld. It hasn't been generated. Why is it so? This is because now I set I'm actually going to connect the whole member, the whole column, welded to the plate, which doesn't make sense, right? So that would weld all the edges, all the parts of the column. So if I open this here, it shows me more options. And here I can set or select the top flange of the member. And that allows me to weld just the flange of the column to that plate and select its the edges I'd like to add the welds to. So if I switch here to transparent mode, you can see these small numbers here, 1, 4, 2, and 3, and those are the edges numbers of the top flange. So I would like to have it in at edges 2 and 4, of course. So just type it here, And if I switch back to solid, I can see the welds in position just as I like it. Okay. Oh, that's one trick, how to weld members to plate, or especially eye sections and hollow sections, and so on. So that's done. And another thing, I'll continue with adding a stiffener to the column. So I'll just select the stiffen operation. This will be on the column, and this will be related to, as you can see now, it's some stiffener on top of the column. If I switch or select here a related member, it aligns the stiffeners with the flanges of the related member and adds a second row, or the down row here to align it as well. Okay, here I changed the thickness of the stiffeners to 6 millimeters and switched the welds to only one side fillet weld and inputs the correct size of 4 millimeters. So this is looking fine over here, but on the other side, if I rotate the model, you can see the welds are displayed on the wrong side. So this is actually from the point of view of the finite element analysis. This is not a mistake. It doesn't matter actually. It's the same as on this side. The weld is created. What you see is just a 3D display or the graphic display of the model, but for the finite element analysis, doesn't matter. But even if you'd like to really have it the same, because we, for example, print out the pictures and we want to have it on the right place, right? Because we are going to show it to somebody, to anybody. So how to treat that? I can use this, my second tip or trick I want to share with you today. So I simply split the stiffener operation to 2. So here I say I'll use the stiffeners only for the rear or this side of the column, right? And copy it once more, use it for the front side, and change the position of weld. Okay. So now this is what I wanted. So that's let's say a small workaround or tip how to polish your 3D model, the 3D presentation of the analysis model. Okay, and the last thing is the anchoring, right? So the anchoring or the base plate or foundation or whatever is usually done by this base plate operation, but this is quite a predefined complex operation that creates the base plate as well and everything around it, which is not suitable for this situation because I've already got the base plate in position and so on. So I only want to create the concrete block and the anchors, and for that I can use ball grid, the general bolts operation, and here I switch to anchors. And now I modify the operation because now it's not really looking okay, but don't worry. I will first shape this foundation block. So here I set that this is the concrete block is under not EP1, which is the end plate, but the SP1, which is the base plate. And here I can switch the sides or the surface to which the base plate is created or attached. So this is looking good now. I can shape the concrete block, which is actually a cut of the wall. So I think 400 millimeters of offset would be enough, let's say, space for calculation the stresses in the concrete and the calculation of anchors in the concrete. So I have enough space. I can make it larger. Let's say 600. I think 400 is in this case, let's say, reasonable value. And the depth is actually the thickness of the wall, right? So this is the cut of the wall, and here we are anchoring the balcony around here. So here the last thing, I will switch from friction, which wouldn't actually work here, of course, to anchors, right? So everything is balcony is hanging on the anchors here, right? And now I go back to these first two bunch of settings. Here I say I'm connecting or anchoring to just one plate, and that's this one, the stiffening plate, and I'll add the anchor size, which is M24, and change the anchoring length. Right now, the thing is, we want to, if I change the length here, for example, like this, and I put it also in position to have it all prepared to the last tip I want to tell you about, right? So this is now in the good position. I will also use the washer plates, let's say this size. And now this joint is anchored to this concrete block somewhere inside. But in our case, the anchoring or the joint, the anchoring type is going all through the wall, right? And there is some on the other or the inner surface of the wall. There is probably going to be some kind of a steel plate holding the whole thing onto the wall. This is not possible to model in IDEA StatiCa, to put here some kind of steel plate and connect it with the joint through a wall and co-check it. But the last tip from my side is, let's say, a small workaround, because we can simply here move the end of the anchors just right behind the inner surface of the wall, and by doing so, we make sure that this is going to work right, is going to write correct, and we've got for example, the concrete cone breakout calculated from the inner side, right, of the wall, and so on. So this is actually the best workaround or best tip what you can do when you want to model a all-through anchoring through a concrete wall or concrete block. So this is now done. I can let it calculate now, but to cut the presentation time, this calculates these 30, 40 combinations. I have done this for you before this webinar, so just to show you the results already calculated. So this is it. You can see it's been co-checked for all those combinations. Everything looks right. The joint is well designed. We've got some let's say usage or utilization for this combination, which now is the most extreme or the most dangerous, this ELU1. and for this one, we've got the utilization of these welds for 98%. And of course, we can now study the results and go through all the checks and so on, and print out the report and so on. And I want to show you this today. So now, if I save this one, close it, it shows me again the robot and the project manager launched within my robot project. And it shows me, since I model a joint and save it, it shows me this list of connections exported from this project. Right, so now I can close this one and save the robot and so on, close it, open again. I can reach this joint again while launching the project manager. Here I can open it again, modify it, or synchronize with anything modified within the robot project. So that would, this synchronize would upload my joint with, let's say, new load combinations or changed cross section or anything that I do in robot. It can recalculate the joint as well, delete it, and manage the list. And of course, I can continue my work now by exporting more joints from this project. So I can here have a list of 3, 8, 20 connections or joints within this one robot project and manage it in this project manager. And yeah, so that's it.
Thanks, Adam.
Yes.
Yeah.
No problem.
Thank you.
Welcome. Always
for your
welcome.
example. And we should move to another example, but we have a poll for you, one more. So
yes,
Adam will show you.
I will pass the presenter now to Jana. And in the meantime, before she starts her part of presentation or her part of the webinar, I will launch another poll for you. So please vote in this one as well. And this is a question for you. How do you co-check a simple connections? The most simple ones, just simple end plate or simple fin plate. If you use for this your IDEA StatiCa software, or if you have some kind of Excel sheet prepared for that, or if you use, let's say, another software, more simple one probably, or whether you don't co-check them at all, if you work with only, let's say, complex joints, or you just let's say, some spreadsheets for the very simple ones. Okay, couple more seconds and we're good to go. So I'm closing this one and I'll share the results with you. And this is now very interesting, quite surprising for me. I've been observing this during your voting. Almost half of you uses IDEA StatiCa for the simple connections as well. This is very nice. That's good information. And a lot of you use also another software that's probably more convenient or simple for you. And some of you use Excel or don't co-check these simple connections at all. All right, thank you very much for this vote. That's very interesting to see and share with you as well. And now Jana is going to show you actually a comparison how you can take advantage of the IDEA StatiCa co-checking this most simple connections.
Yeah, okay. So
that's it.
Can you see my screen now?
Yes.
Yeah. Okay, so that's great that you are using IDEA StatiCa also for simple connections, because it's really a powerful tool and it's fast and it's easy to use and you have a visual control of what's happening. And in my short example, I just wanted to demonstrate the workflow, the comparison between Excel workflow and IDEA StatiCa Connection. Therefore, I have a sketch of such connection. There are two beams connected to a column through an end plate, and now I want to check it in Excel sheet. Therefore, I had to find the correct one, which is sometimes quite hard work to find something, or of course you can create something, or you get something from your colleagues or from your company. I'm sure that all of you have some Excel sheet, maybe your own, or maybe some already created. I have found this on internet. It's based on Eurocode, and it's dedicated to this specific connection. So there is no variability in the design. I need to follow only this sketch. So I can, of course, change the dimensions, but I'm not able to change the topology at all. So let me go through this Excel. I will fill only the blue values here, and I will start with the steel grade to S555, sorry, 355. And now I'm supposed to fill something about the end plates. So the L, I always have to search for the correct parameter. It's the height of it. So let's put there 410 millimeters. For the B, which is the width, 150, and the thickness, 15 millimeters. I will skip these partial safety factors, and I will continue with the input of the cross sections. For my column, I want it to be HEB 300, which I need to find, and it's not always so easy, and it's this one. And for beams, I will put there IPE 300. So it's here. Okay, you can see there's a huge list, and it's quite difficult to find the correct ones, but now we have it. Okay. For the bolts, I want to have 8.8 with the size M20. Okay, and now I have to change the spacing of it. So for the W value, this W value is equal to C, which is the span between the two columns of bolts. So in my case, it's 80 millimeters, and the additional value is the distance to the edge, which is in my case 35. And now the first row of bolts will be 50 millimeters from the top. It's this parameter, and also 50 millimeters from the I section. Great. And the other two rows will be always 50 millimeters. Okay. And the last thing that I have to select is the weld thickness, because the I section is welded to the end plate. So let's put there 6 millimeters for flanges and for web as well. I have this E1 parameter, which I have to search in another picture. It's somewhere here. Yeah, it's the distance of the free edge of the column from the top row of bolts. So in a case that the column is continuous, we will put there 1000. And that's it. So if I'm really familiar with the Excel and I really know exactly what values to input, I already know all these schemes, it's also quite fast. And I have a very long document with all the equations related to component method. Of course, the Excel is based on component method, which is something different to IDEA StatiCa Connection. the Excel checks all the possible modes of failure and decides between the worst one. And so in the end, I have some resistance regarding the bending moment and the vertical shear force. And that's all. Now let me skip to IDEA StatiCa to show you how you can do that in our software. So if you open a new project, you have a library of some predefined connections. In our example, we will select this column and beam, and always we will follow the most similar topology and design. So you can see this is the library of final designs. In our case, probably the end plates are the closest to our sketch. I will change the steel grade and the bolt assembly. Of course, you can change it any time after. I don't have to take care of concrete grade, and in my example, I will follow the Eurocode. Now, let's create such a project. And as there were no stiffeners in our examples, I will simply uncheck the stiffener operation, and they disappear directly. So let's change the cross section of the column. You can see that the library it's much more friendly if you want to search something specific. It's not only one list, but it's ordered list. Okay, we can change the other one as well. Nice. Now let's have a look at the end plate operation. So I will simply change these parameters. I will change the thickness of the end plate. You can write there a number, or you can scroll the mouse to change the values directly. As we want the end plate to be higher, we will change the dimensions not to be symmetrical, and we will put 100 millimeters on the top and 10 millimeters on the bottom. We don't want backing plate here, and we already set the bolt grade, of course, and now we will define the rows of bolts. So for my top bolts, they are 50 millimeters on the top. I will change also the distance from the edge, from the left and from the right. And we also want another 2 rows. Sorry, it's minus 50. And we want 2 rows of bolts on the top, so it's like this. And from the bottom, let's place it 50 millimeters from bottom, but maybe you mentioned that in the Excel there were no possibility to set the distance for the bottom bolts, because the component method doesn't count with these bolts as they are in compression. So they only counts with the bolts in tension. Of course, the method in IDEA StatiCa Connection is a little bit different, because we are a finite element model-based tool. So we really calculate the stress and strain within all these plates and bolts. The last thing that I need to change are the weld thicknesses. Okay, and I think I'm ready to go. So maybe let's change the values of the shear force to what we have received as the resistance, just to have a picture about the behavior, which is quite close to limits. And I will start the calculation. It should be quite fast because it's really simple connection. And we have results. Of course, you can see it's all green, only the welds are orange, which means they are quite close to the limit. And You can see all the stress information, also the plastic strain, if we are interested in that. For the bolts, we can display the bolt force, and if I click on a specific bolt on the vector, it opens me the corresponding line in the table. I can open the code check equations, and I can display. You can see it's not so long because we are not assuming different failure modes. We are really calculating with the correct ones because we know what's the stress and strain in the connection. And of course, we have a report which you can adjust according what you need and also print out. Maybe let me mention one more thing. In the next version, which will be released in April this year, we will have much wider library of connections. And of course, maybe I can show you one more thing. The library of predefined design is not only when you start a new project, but it's also accessible via the right mouse button. And if I select the connect to option and I select the column, it opens me the library as well. So you can see I can simply create a connection like this, and it's done. Okay, so we have quite a long webinar today, so let me just very quickly show you two selected questions that we have received. The first one was about the beam links. Adam has shown the beam link with Autodesk robot structures, and there was a question if we are connected also to SAP 2000. So let me show you where you can find all this information. Of course, we are connected to SAP 2000, and not only SAP 2000, but also other softwares. You can see all the list here. If you go to our web page under the BIM tab, you can see not only the list, but also the workflow. If you open specific software, you can play a video with a short demonstration. You can open tutorial where it gives you an idea how to work with it step by step. And there was another question. It's on you, Adam. So the question was, can we check the anchors also when they are bound with the reinforcement of the footing?
All right.
Maybe you can show us your example.
I'll take the presenter. Okay. All right. First, thanks Anna for nice comparison. It takes a bit longer today, but we have just so much to say. So this question about how to treat when the anchoring is connected or bound to reinforcement in the concrete, right? If I understood that correctly. So in this case, what we see, there is no reinforcement in the concrete wall, and the anchors are just right in there. And if there was reinforcement and the anchors were bound to those, of course, that would result in much more positive situation for us, and help us to get, let's say, a more reasonable design of the anchoring, right? How can we treat this in IDEA? Well, there is, let's say, one workaround. This is the, let's put it like this. This is in development right now to have a real model of reinforcement concrete and anchoring in this reinforcement concrete footing or whatever. So this is now in development, but this is going to take a bit longer time. But for now, there is a simple workaround. If we go to code setup, and here we take a look at this concrete breakout resistance, This is now applied, right? So we calculate that and we code check if the plain concrete holds the whole thing, the whole anchoring in itself. But if we turn this off, that means we neglect that, and that is the case actually when you have the anchoring bound to this reinforcement, right? Because that means it cannot be broken out from the concrete. So this is the workaround for that. So you can try this and then see what it does in the results, how it helps you.
Mm-hmm.
Right, and maybe have one more question here. I was just answering and those in chat. There was one interesting from Attila Shabo. If he struggles when he has a lot of combinations, for example, in this case, we have, let's say, I don't know, 40, and so that takes some time to calculate them, right? So if you have complex joint and a lot of combinations, that could take maybe, I don't know, 15, 20, 30 minutes to calculate all of them. So how can we improve that? We are developing, and it's nearly done. It's going to be released in the next version, a cloud-based calculation. So you actually send, if you click here to calculate, the calculation is not being done on your computer, but in the cloud, somewhere in the internet servers, and just sends you back the results. So you cut this calculation time dramatically because you simultaneously calculate all of those combinations at the same time. And so actually the calculation time then is just based on one combination calculation time, right? So this will be much, much faster in such cases. So thank you for these questions.
Yeah, let me take the presenter again, and I will conclude our webinar. Sorry. So thank you very much for your attendance. After the webinar, we kindly ask you to fill a short survey about what you liked, what you didn't like during the webinar, what you want for the next webinar. The recording will be also available from tomorrow on our website and also on our YouTube channel. You can apply for our trial version on our web. And of course, if you want to find some specific information or you want to study Ideastatica more, please go to our resource center on our web page, which is full of information. For the next webinars, you can look forward to another Connection Wednesdays on March 18. It will be a shaft tower connection from Thames Tideway Tunnel. So it will be prepared by our UK team. So very interesting project from Praxis again. And of course, we are now preparing or finalizing the version 20. So we will present the new features in our release webinars. You can mark in your calendars that it's on April 29th. And there's also one very last thing that I want to mention here. It's our new baby. It's called IDEA StatiCa Campus. It's a platform for students who want to take part in a course that we prepared. It's called Theory and Practice of Steel Connection Design using IDEA StatiCa. If you want to find more information, please go to our web, ideastatica.com/campus. There are more information about what you can expect in the course, and you can still catch the early bird price till March the 3rd. Maybe let me show you very quickly how the campus looks like. There's a free trial of the campus, so you can enter a part of it for free, and if you are interested, you can get the access to the full course. And you can see there are many topics that should really teach you everything about IDEA StatiCa. And that's really the final word from me. So thank you very much once more. Sorry that we are much longer than usual, but I hope it was useful time. Thank you very much, and we are looking forward to seeing you on the next webinar.
Thanks for having you here. Goodbye. Have a nice day.